Let me show you how to be a good Bayesian. Change your predictions after taking information in.
Basically, that would be this kind of reactive message passing is extremely useful when you receive data in real time that you don't really know the structure of.
Sort of, yes. Yes. We work primarily with real-time signals, yes.
Okay, very interesting. And actually, do you have any examples, any real-life examples that you've worked on or where, this is extremely useful to work on with rxinfo.jl or just in general, this kind of reactive message passing?
Myself, I usually do not work with applications, so my primary focus lies in the actual Bayesian inference engine. But in our lab, there are people who work, for example, on audio signals, right? So you want, for example, maybe create a probabilistic model of environment to be able to denoise speech. Or it may be like a position tracking system or a path planning system in real time. In our lab, we also very often refer to the term active inference, which basically defines a probabilistic model not only of your environment, but also of your actions, such that you can infer the most optimal course of actions. And this might be useful in control applications, also for the drone, right? So we want to infer not only the position of the drone based on sensors that we have, but also how it should act to avoid an obstacle, for example.
Yeah, okay, super interesting. So basically, any case where you have really high uncertainty, right? That kind of stuff. Okay, yeah, super interesting. What prompted you to create a tool for that? What inspired you to develop rxinfo.jl? And maybe also tell us how it differs from traditional Bayesian inference tools, be it in Python or in R or even in Julia, right? If I'm a Julia user, I'm used to use probabilistic programming language in Julia, then what's the difference with rxinfo?
This is a good question. But there are two questions in one. So about inspiration. So I joined the Bayes lab in 2019. Without really understanding what it is going to be about. So without really understanding how difficult it is, really. Mm-hmm. And the inspiration for me came from the project I started my PhD on. Mm-hmm. And basically, the main inspiration in our lab, the so-called the free energy principle, which kind of tries to explain how natural biotic systems behave. Right. So, and they basically say, they define so-called Bayesian brain hypothesis and free energy principle. So they basically say that any biotic system, they defines a probabilistic model of its environment and tries to infer the most optimal course of action to survive, essentially. But all of this is based on Bayesian inference as well. So, right. At the end, it's a very good idea, but at the end, it all boils down to the Bayesian inference. And basically, if we look how biotic systems work, we note that there are very specific properties of this biotic system. So they do not consume a lot of power, right? It has been proven that our brain consumes about 20 watts of energy, right? And it's extremely efficient device, if we can say, right? It does not even compare with supercomputers. It's also scalable because we live in the very complex environment with many variables. We act in real time, right? And we are able to adapt to the environment, and we are also kind of robust to what is happening around us, right? So if something new happens, we're able to adapt to it instead of just failing, right? And this is kind of the idea. So the inspiration for this Bayesian inference toolbox, that we need to be scalable, real-time, adaptive, robust, super efficient, and also low power, right? So this is the main ideas behind rxinfo project. And here we go to the second part of the question, how does it differ? Because this is exactly where we differ, right? So other solutions in Python or in Julia, also very cool. There are actually a lot of cool libraries for Bayesian inference, but most of them, they have a different set of trade-off or requirements. And maybe I will be super clear. We are not trying to be better but we are trying to be like, we're trying to have a different set of requirements for the Bayesian inference system.
Yeah, you're working on a different set of needs in a way.
Yes. And it's like application driven.
Yeah, you're trying to address another type of applications.
Exactly. And if we directly compare to other solutions, right, they are mostly based on sampling, HMC or NATS, or maybe they are like black box methods like ADVI, automatic differential variational inference, or BBVI. And they're great methods, but they tend to consume a lot of computational power or like energy, right? So they do a very expensive simulation. It may run for maybe hours, maybe even days in some situations. And they were great, but you cannot really apply it in these autonomous systems where you need to, like if we're again talking about audio, it's like 44 kilohertz. So you need to really perform Bayesian inference at an extremely fast scale, and HMC or NATS are not really applicable in this situation. So
yeah, fascinating. And you were talking, well, okay, we'll get back to the computation part a bit later. Maybe first, I'd like to ask you, why did you do it with Julia? Why did you choose Julia for RxInfer? And what advantages does it offer for your applications of Bayesian inference?
The particular choice of Julia was actually like driven by the needs of the Bayes lab in the university, because all research which we do in the university now in our lab is done in Julia, and that decision has been made by our professor many years ago. And interestingly enough, our professor doesn't really code, so. But Julia is a really great language. So if I would choose myself, I would still choose Julia. It's a great language. It's fast, right? So and our primary concern is efficiency. And like Python can also be fast if you like know how to use it. If you use NumPy or like some specialized libraries. But with Julia, it's really easy. It's easier. Mm-hmm. In some situations, of course, you need to know a bit more. So my background is in C and C++, and I understand like how compilers work, for example. So maybe for me, it's a bit easier to write a performant Julia code. But in general, it's just really, it's a nice, fast language. And it also develops fast. So in a sense that new versions of Julia, they come up like every several months. And it really gets better with each release. Another thing, which is actually very important for us as well, is macros, our macros in Julia. So for people who are listening, right? So macros are basically allow us to apply arbitrary code transformations to the existing code. Mm-hmm. And it also allows you to create like a sub-language within a language. And why it is particularly useful for us is that specifying probabilistic models in Bayesian inference is a bit hard or like tedious. We don't want to directly specify these huge graphs. And instead, what we did, and what Turing also did, and many other libraries in Julia, they came up with like a domain-specific language for specifying probabilistic programs. And it's extremely cool. So it's much simpler to define a probabilistic program in Julia than in Python, in my opinion. And I really like this feature of Julia.
Let me show you how to be a good Bayesian. Change your predictions after taking information in.